Hello everyone, welcome to eMath Edge. My name is David Akwashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMath Edge, I'll practically be solving mathematics past questions for senior school examinations, where I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for maths exams can really be hectic. But understanding how to approach these questions, most especially the AC part, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video is designed to boost your confidence and make maths exam feel less like a mystery, but more like a basic thing you can conquer. So with that being said, let's get started. So here we have a metric question which says, let matrix A be equal to 1, 2, 3, and 4. Show that A square minus 5A minus 2 identity matrix is equal to 0. So let's go ahead and solve that problem. We have solution. Let's bring out the matrix A, which is containing the element 1, 2, 3, and 4. Where we are to show that A square minus 5A minus 2I is equal to 0. So if you observe, this expression is having three different terms. A square is a term on its own, negative 5A is a term on its own, and negative 2I, which is 2 identity matrix, is a term on its own. So we are going to be obtaining each of these terms. Since we have matrix A, it will be easy for us to obtain A square. So now, to obtain A square, we are going to have A square to be equal to, now this is matrix A, and in this case we are looking for A square, and you know that another expression of A square is A times A, right? So that's to say we are going to multiply this matrix by itself. So it's going to be the matrix 1, 2, 3, and 4 multiplying itself, which is going to have the same elements as 1, 2, 3, and 4. Now this brings us to matrix multiplication. I know once it comes to matrix multiplication, how we do it is you pick the first row to multiply the first column for you to have the element in the first row, first column. So let's go ahead and do that. Elements in the first row by first column, we are going to have 1 multiplied by 1 plus 2 multiplied by 3. Now, to obtain the element in the first row, second column, we are going to multiply the element in the first row for the first matrix by the element in the second row for the second matrix. So it's going to give us 1 multiplied by 2 plus 2 multiplied by 4. Now, the next thing we are going to look out for is the elements in the second row, first column. And for us to achieve that, we pick the element in the second row for the first matrix, multiply by the element in the first column for the second matrix. So it's going to be 3 multiplied by 1 plus 4 multiplied by 3. The next one is to obtain the element in the second row, second column. So for us to achieve that, we pick the element in the second row for the first matrix, multiply by elements in the second column for the second matrix. So it's going to give us 3 multiplied by 2 plus 4 multiplied by 4. So With this, it will be very easy for us to simplify. So let's go ahead and simplify this expression such that we are going to have, now 1 multiplied by 1 is going to give us 1, plus 2 multiplied by 3 is going to give us 6, right? So this is the element in the first row, first column. Down to the element in the first row, second column, we have 1 multiplied by 2, which is going to give us 2, plus 2 multiplied by 4 is going to give us 8, right? The next one is the element in the second row, first column. So 3 multiplied by 1 is going to give us 3, plus 4 multiplied by 3 is going to give us 12. So we have this. Now the element in the second row, second column is going to be 3 multiplied by 2 is going to be 6, plus 4 multiplied by 4 is going to give us 16. Now we simplify this a little bit. We can still simplify further by adding up all these elements in the bracket. So let's go ahead and do that as well, such that we are going to have, now 1 plus 6 is going to give us 7. 2 plus 8 is going to give us 10. 3 plus 12 is going to give us 15. And 6 plus 16 is going to give us 22. So this is A square. We multiply matrix A by itself to give us this matrix. Now the next thing we are going to be obtaining is the negative 5A. But we are going to leave the negative sign first. We are going to obtain 5A. After which we will come back to solve for the entire expression. Then we can apply the negative sign. But for now, let's go ahead and obtain 5A. Since matrix A is given, we are going to multiply the scalar value, which is 5, by the matrix A. So let's go ahead and do that. To obtain 5A, 5A is going to be 5 multiplying the matrix. And what are the elements of the matrix? We have 1, 2, we have 3, and 4. So in this case, this is the scalar value, which is 5. Is going to multiply each of these elements such that we are going to have 5 multiplied by 1 is going to give us 5. 5 multiplied by 2 is going to give us 10. 5 multiplied by 3 is going to give us 15. 5 multiplied by 4 is going to give us 20. So the expression 5A resulted to this matrix, which have the element 5, 10, 15, and 20. Now the next thing we should be looking out for is how to obtain two identity matrix. We are going to leave this negative sign as well. We are focusing on 2I, and you know I stands for identity matrix. And what is identity matrix? Now let's go ahead and solve that. Now to obtain 2I, 2I is going to be 2 multiplying identity matrix. We have a 2 by 2 matrix to work with, which is matrix A. Therefore, we are introducing a 2 by 2 identity matrix as well, where we have it to be 1, 0, 0, 1. So if you are to multiply the scalar value, which is 2, by this identity matrix, we are going to have 2 multiplied by 1 is going to give us 2. 2 multiplied by 0 is going to give us 0. 2 multiplied by 0 is going to give us 0. 2 multiplied by 1 is going to give us 2. Now we've succeeded in obtaining the matrix for A square, which is this. We've also succeeded in obtaining the matrix for this term 5A, which is this, and that of 2I, which is this. So it will now be easy for us to substitute these matrices into this expression for us to verify if it will be equal to 0 or not. So let's quickly go ahead and do that. Compute a square minus 5e. Now, a square minus 5e, what is matrix e square? We've obtained it earlier to be 7, 10, 15, and 22. So we have it to be 7, 10, 15, and 22, right? Minus, what is 5e? We've obtained it earlier to be 5, 10, 15, and 20. We have it to be 5, 10, 15, and 20. This led us to subtraction of matrices. Since we have 7 to be the element in the first row, first column for the first matrix, we compute it with the element in the first row, first column of the other matrix. If it is addition, we add, and if it is subtraction, we subtract. So in this case, it is subtraction. So let's go ahead and do that. 7 minus 5. Now for this other matrix, which is the first row, second column, is going to be 10 minus 10. So we are going to have 10 minus 10. In this case, we have 15 minus 15. So it's going to be 15 minus 15. And the last but not the least, 22 minus 20 is going to be 22 minus 20. So to simplify further, we are going to have 7 minus 5 is going to give us 2. 10 minus 10 is going to give us 0. 15 minus 15 is going to give us 0. And 22 minus 20 is going to give us 2. So a square minus 5a, we've obtained this matrix, right? So now let's go ahead and solve for the entire expression, which is we have a square minus 5a minus 2i, right? Where we already have a square minus 5a to be equal to, we just obtain it, right? Which is 2, 0, 0, 2. And we have 2i to be equal to 2, 0, 0, 2. So now to substitute this matrices into this expression, we are going to have a square minus 5e minus 2i to be equal to a square minus 5e is this, right? So let's substitute it. We have 2, 0, 0, and 2 minus 2i, which is this, right? So let's substitute it as well. We are going to have 2, 0, 0, 2. So let's simplify this further. We are going to have 2 minus 2, 2 minus 2. That's for the first row, first column. Now for the first row, second column, we are going to have 0 minus 0, 0 minus 0. For the next one, we are going to have 0 minus 0 as well, 0 minus 0. And the last one, which is 2 minus 2. 2 minus 2. So if you are to simplify this matrix further, we are going to have 2 minus 2 is 0. 0 minus 0 is 0. 0 minus 0 is 0. And 2 minus 2 is 0. Now, since a square minus 5e minus 2i gives us this matrix, which is 0, 0, 0, 0. This implies that a square minus 5e minus 2i is equal to 0. This shows that we have successfully proved that this expression is equal to 0. So with this, we have come to the end of this video. Stay tuned and engaged for the next one. Also remember that goal of this platform is to solve as many past questions as possible, just to help you overcome what I called math exam tension. So if you have any challenging question from this topic you would like me to help you solve, kindly drop them at the comment section or send me an email or DM and I'll be glad to assist. Thanks for watching and have a great day.